Hi, my name is Emma, and for the protein project, my protein was COL1A1. This protein is located within the extracellular matrix of the cell. Its mutation is at position 836, and it's when arginine is replaced with cytosine. This mutation causes Caffey's disease. Caffey's disease impacts the collagen structure and function, and in this case leads to excessive bone formation and inflammation, especially in the diaphyses of the long bones, clavicle, and mandible, and this is more common in infants. On the cellular level, this mutation compromises the extracellular matrix that results in excessive bone thickening, swelling, and irritation. This mutation disrupts the charge balance because arginine is a positively charged amino acid, while cytosine is a sulfur-containing amino acid. This mutation also impacts the hydrogen bonding, which impacts the protein's proper folding and stability of the triple helix. The overall 3D shape of my model involves a triple helix structure. As you can see here. This protein has two subunits because two of the chains are alpha 1 and the other chain is alpha 2. This is represented in my model by having two of the chains be red and the other chain is silver. The primary structure is shown in my model through the beaded chains. This is an example of what it looks like. And I have painted the bead at position 836 green in my model, just to highlight where this mutation occurs. You can see it right there. The secondary structure involves the local folding of the amino acid chain into specific shapes, such as alpha helixes and beta sheets. In COL1A1, the secondary structure predominantly forms a left-handed helix. So this shows the local folding. And this is an example of kind of what that local folding per each of those strands looks like. I've used just a little stick here just so that you could see the individual structure. The tertiary structure is the overall 3D dimensional shape. For COL1A1, the tertiary structure is characterized by the formation of the triple helix, this is where these come together to form the right-handed superhelix. The quaternary structure is the level of structure that refers to the assembly of multiple protein molecules into a larger complex. So this would be when multiple of these proteins are together to form a type 1 collagen fibro. The limitations in this model include the simplicity of the protein structure and all of the bonds that go into stabilizing this triple helix. For example, the hydrogen bonds are not shown between the individual molecules in my example. In addition, another limitation is the proteins in the body are more complex than shown, and they're constantly being impacted by their environment and the conditions within the body, which is not able to be represented in my model here because it's not in the body and it's just a physical representation. Lastly, my last limitation is how on my model I have painted position 836 green to highlight where the mutation occurs. However, in the actual protein, it's not highlighted green. I just did this for visual representation to make it easier so that you could understand what spot I was talking about for the mutation within my protein that causes Caffey's disease. And that was my protein project.